Assalamu alaikum. Today, inshallah, we will solve some instruction and planning questions of paper 6. The first question here is about two types of fuels, petrol and bioethanol, and he needs you to decide which one can produce more energy. He's giving two types of instruments, and you have to decide which one you will use in this experiment. First of all, I have to decide or determine what is the theoretical basis that can I use. Here, to produce energy by a fuel, it means the fuel will be burned and the heat released from this burning will be absorbed by water. I can measure the temperature of water before and after burning the fuel, determine the delta or the change in temperature. The fuel that will make water temperature rises more, it means that it releases more energy. Okay. This is the base, and I will just draw the same apparatus that I choose here. I put flame here because I need to make burning or ignition of the fuel. The fuel will be put in a crucible. The heat released can be used or absorbed by water. Temperature of water will rise, and I will compare the rising in temperature as I told before. Okay, so this is the theoretical basis. How can I write these steps practically? You have to imagine exactly that you are in the lab and carry out your steps. Using your glasswares, writing your exact measurements or volumes or masses in grams, writing your units, everything as if you are exactly in the lab and carrying the experiments by your own. So the first step is take 2000 milli of water in a copper can. Second, determine the temperature of water using the thermometer, of course, before and after the experiment. Third, take 10 milli of the first fuel, which is petrol, and start to burn it or heat using your flame, of course. Number 4, the fourth step, after complete ignition, when it is completely finished, now we should determine the temperature of water once again. Calculate the difference in temperature of water before and after the ignition of the fuel. Write it down, of course. Repeat the same steps using the other fuel. So here we wrote calculate the difference in water temperature in both fuels using the same amount. The word the same amounts is very important here. We cannot compare any two substances without using the same amounts, either volume in millis or if it is solid, we should use the same amounts in grams. So when comparing two substances, the same experiment will be repeated using same amounts and same conditions in everything. Okay. Now the last step, to compare the difference in temperature of the first fuel and second fuel, delta T1 and delta T2. And as we said before, the fuel that will make the higher delta H, it means that it produces more energy. Okay, this is the first question. The second one, two types of cleaner, and you need to decide here which cleaner is more powerful. How can I know? He told you that each of these cleaners, it contain a chemical substance which is sodium hydroxide, and we need to know exactly which cleaner contain the higher concentration of sodium hydroxide. Once again, before writing any practical steps, I have to decide the theoretical basis. How can I determine the concentration of sodium hydroxide? What is sodium hydroxide? Sodium hydroxide is a base, or actually it is an alkali or a base soluble in water. To determine the concentration of a base, simply I can make it reacting with an acid. Let's choose any acid, like HCl. Okay, so I will react the cleaner containing sodium hydroxide with dilute HCl or with the HCl. Of course, the cleaner with the higher concentration of sodium hydroxide will consume more volume of HCl. This is the theoretical base. Let's write it down in practical steps. Once again, I'm in the lab and I need to carry this experiment or reaction of sodium hydroxide and HCl. You have to choose all your glassware. Write down any reagent that you should use. First step, in a conical flask, this is the first glassware, I will put 20 ml of my first cleaner using a pipette. Why a pipette here? A pipette is one of the glasswares that is used to measure accurately volumes. What if you wrote a measuring cylinder? It's not good. You will lose your mark here. Why? In comparing concentrations or in calculating concentration, I should use the glassware that's measuring the volume very accurate. So we have only, in measuring volume accurately, we have the pipette and purette. So the first cleaner, we will take 20 ml using a pipette. Secondly, we will add drops of methyl orange as indicator. Especially methyl orange, you can use any indicator, not only methyl orange, but you should mention an indicator. If you didn't mention the name of the indicator, you will lose your mark too here. What is the importance of the indicator? If you are in the lab, you said that you are going to make a reaction between HCl and sodium hydroxide. How will you know that your reaction is ending? How will you know that sodium hydroxide is completely consumed now by the HCl that I'm adding? So the presence of an indicator is very important here to determine the end point of the reaction. Third step, add slowly or drop-wise the titrant, which is HCl, using a purette. Once again, a glassware that is accurately measuring the amount added of HCl. Number 4, when color changes from yellow to orange, this means that the end point of the reaction and complete consumption of sodium hydroxide in the flask. Record your reading, which is R1. This is for the first cleaner. Once again, repeat all the steps using the same amounts of the second cleaner or cleaner 2. And of course, the reading will be R2. Compare the readings of the two cleaners, R1 and R2. The cleaner with the higher concentration of sodium hydroxide, it means it consumes more volume of HCl. The third one here is about fertilizers. Here he's telling that there is a farmer, he's planting beans and he needs to buy fertilizer, either two types of fertilizers, Grow Well or Plant Strong. And he needs the fertilizers that will make improvement of the plant growth. Now I should think once again about the theoretical basis here. What is a fertilizer? A fertilizer is a substance that will be added to plants to improve the growth. It means it will make the growth of the plant faster in a good way. How can I compare two fertilizers? Simply, I will add the fertilizer to the plant, leave it for a while and compare or observe the growth of the plant. If it is improved, so this fertilizer is good and I can use it. Let's write the practical steps once again. Take 1 gram of the first fertilizer. Should I specify the amount? Yes, of course. In adding, comparing, once again, when we compare two substances, we should specify amounts. 1 gram, 2 grams, 5 grams, whatever you will write here, you will write it for the second fertilizer too. Take 1 gram of the first fertilizer, which is Grow Well. Add it to the soil and the bean that he is going to grow. Add water daily, of course, irrigation, for at least 1 week. Why I mention time here, and this is very important here. At least 1 week for plant to grow and you can observe the improvement in growth. But if you didn't mention the time here, you will lose your mark. If you said that after 2 hours, let's observe the plant growth. How can a plant grow in 2 hours? This is magic, not fertilizer now. Okay, so leave it for 1 year. It's wrong too. 1 year, all plants will be in the same size now. You cannot compare after 1 year. So you have to choose the moderate period of time that can allow your experiment to succeed. Here for plants, it's about 1 week. In some experiments like rusting or corrosion of metals, you will make your experiments and leave it for a time too. Don't you have to specify the exact time that's needed for corrosion. For example, if you will make the corrosion process in sunlight, so you will mention leave it in sunlight, for example, for 1 month. If you will heat by yourself, you will heat water in which you will add to the metal or immerse the metal nails inside it. This hot water can accelerate or fasten the corrosion process that can happen in 3 or 4 days, but never in 1 day. Corrosion will never appear in 1 day. So please, when your experiment is acting or considering a slow reaction, you have to specify the moderate time or period that's needed by this reaction to happen. Number 4, after leaving for 1 week, we will repeat, of course, all the previous steps using the same amount, which was 1 gram of the fertilizer, but using the other kind, which is plant grow. Now, after 1 week, observe the growth of both plants. See which improvement, or compare the results, which plant was improved by the fertilizer added to it. The plant with more improvement or the higher improvement, it means that it received a good fertilizer.